Day 5 homework time. Today we focus on dilations. Now, in the first part of this, we're just going to make the connection between the kind of number that the parent graph is being multiplied by and then the kind of dilation that takes place. You do not have to graph them. Notice with the instructions it says for each question, state whether each graph will be the result of a vertical shrink or stretch. You're just going to write stretch or shrink to the right of each equation. No graphing. Some of them you don't know how to graph yet, and that's the point. The point is math is consistent and it will work regardless of the parent graph. Then for part 2, I'm asking you to practice doing some of these dilations with parents we know. So we'll pause it when it's time so that you can get your parent graphs filled in, but notice I've already done that. Again, saving a little bit of time because we're at a point where the parent graphs should be second nature. You're going to continue to be popped quizzed on them and so forth. So let's go back to the beginning. Day 5, stretching and shrinking. Here was the big deal, and hopefully you noticed this as you went through your different Inspire activities and labs during class time. If not, we will be doing more of this in class tomorrow. Tomorrow's like that last ditch effort to try to make the connections with dilations, because dilations are pretty tough for a lot of people. But here's generally what happened. When you have a whole number in front of your parent graph, here I have 3 times square root of x, 2 times the absolute value of x, negative 4 times. The 4 is the part we look at for the dilation. We know that the negative is a line reflection, okay? This one, 4 over x, and I give you a hint, it's equivalent to 4 times our parent graph of 1 over x. So when we see these whole numbers out front, numbers greater than 1, 3, 2, 4, 4, those are vertical stretches. Big numbers stretch. Okay, that's a way to remember it. So we're going to write stretch next to 1. We're going to write stretch next to 3. We're going to write stretch with 6. And we're going to write stretch with 7. Okay. With the math being so consistent, then we can see that with fractions as leading coefficients, as numbers out in front of my parent graph, 1/4 of the parent x cubed, 1/2 of the parent x squared. Again, this negative is a reflection. 1/3 of this parent log. When we see a fraction, fractions make things smaller. Fractions are a vertical shrink. So next to those, we'll write the words shrink for 1, 2, 4, and 5. And that's the general idea. So let's practice that a little bit. Again, this is when you may want to pause and get your different parent graphs drawn in. Great practice for those pop quizzes that you're going to continue to see. And I'm going to move right through these. So for number 1, we have the parent graph square root of x. Remember we said we identify our parent by that most basic thing happening to x. Out in front of it, I'm multiplying by 3. Big number, stretch. So I'm going to do a vertical stretch 3 by 3. So I take all my distances. 0 times 3 stays 0. Take this distance from x. 1 times 3 stretches to 3. This distance, 2 times 3 stretches to 6. And this distance, 3 times 3 stretches to 9. And there is the child. And truly, it's meant to be quick. Dilations are the toughest part. Keep practicing, and we'll practice more in class tomorrow. 1/4 is a fraction, so it's a shrink. Fractions shrink. So I'm going to go 1/4 of the distance back to the x-axis. This point is 8 units away from x. 1/4 times 8 is 2, so that shrinks back down to 2. This point is 1 away, so that's going to shrink back to 1/4 away. You have to estimate that. We don't have that as a scale. 0 times anything stays 0. This distance is 1 away. 1/4 times 1 is 1/4. This distance is 2 away. 8 away. 8 times 1/4 is 2. Let's think about my answer. And there is that child graph. Okay, last 2. 2 times the absolute value of x. It's a 2. Big number, stretch. So I'm going to take all these points, measure their distances from the x-axis, and then multiply those distances by 2. So 0 times anything stays 0, 1 times 2 stretches to 2, 2 times 2 stretches to 4, 3 times 2 stretches to 6, 4 times 2 stretches to 8, and so on. Same thing happens on the other side. Again, I'm really hoping you're getting to the point where you're going to be this quick at graphing them too. No inspires necessary. Just some basic transformation rules. Now this last one has 2 things going on, which is a sneak preview of what we'll be doing in the next week. We have a negative, which we know is a reflection, and then we have a 1/2, which is a dilation that's a shrink, vertical shrink, because it's a fraction, fractions shrink. So we do this one step at a time, thinking about PEMDAS and how this really means -1 times 1/2 times the parent x squared. So I've already drawn in my parent, and then when I multiply, we work in order from left to right. So I'm going to reflect before I dilate. So I'll take all these points and reflect them like we did the other day. And then I take that new graph, kind of an intermediate middle child, you could say, and I take those points and I shrink them back toward the x-axis halfway. So 0 stays 0, half of 1 is half, half of 4 is 2, half of 9 is 4.5, half of 4 squared is 16, so half of 16 is 8 if you want another nice point to really get the width in there. And then again, it's the same on the other side. And that is it. So, we have really completed all of the different transformations that we're going to learn this year. Sorry. Now what we do is we put it all together. In class tomorrow, we will do more dilations, making some discoveries on your Inspire. And then we'll be pulling things together. I'll give you a picture and you're going to determine its equation without the Inspire. I'm going to give you an equation and you're going to graph it without the Inspire. Remember, colored pencils will really be helpful as we go through this because we're going to have multiple transformations happening to one function. So we're going to be translating and dilating and flipping and translating again maybe. So we're going to be moving a parent many times. So you may want to color code in order to help you see the different steps. So if you can, bring some colored pencils from home. Crayons are okay, but sometimes they're a little fat for our graph paper, so really colored pencils are best, or a light colored pens that won't bleed through your paper. That's it for me. Have a great day, and I'll see you tomorrow.